Yeah, so, I thought I was going to do my own introduction in a sense, right? So I thought, okay, well, here's a picture of me at the Scottish Rails Conference. It was last year, I guess. No, year before. And I was invited by some people over there. They said, oh, Mike, why don't you come and keynote at our conference? I'm kind of like, me? Why me, right? Because I haven't really been involved in the Rails community at all. And that's kind of weird. I hate being the guy who goes and visits and, doesn't really know exactly what's going on in a particular community. I've gone to several conferences where people have done this sort of thing. And it kind of freaks me out a bit because they go and they say things like, oh, you guys should do this and you guys should do that, and they don't really know. I don't want to be that guy, right? So anyway, I'm here, right? So I'm going to go and talk to you about a couple of things that are a little bit off to the side of legacy in a sense. I am kind of known for this book, working effectively with legacy code. But the thing that I kind of surmise is that, whoops, the double jump. The thing I surmise is that that you don't have much legacy code, right? Or do you? Yeah, okay, so I just heard you guys do have legacy code. The funny thing is I've never really been called into a Rails shop at all. Right? I've never really seen this. And it's a very strange thing for me also because when I wrote this book, I have only a little bit of Ruby in it, okay? And most everything there is dealing with Java and C# and dealing with C++. And the thing that's really hard in those languages is breaking dependencies well enough in order to go and write tests. And in fact, about a year ago, I wrote this little paper called Testable Java. And it was all about how you can avoid the use of certain constructs in Java in order to go and actually sort of make things more testable. And I felt like, well, gee, if I wrote a little paper called Testable Ruby, it would just be one line, Ruby is testable, right? Because in essence, you don't have all these little artificial things like final and static and all these things which kind of get in the way of going and giving you access to the objects and the pieces that you need to go and really start to write tests and understand what your code is doing and all that sort of thing. Basically, Ruby is an open book. You can do just whatever you want to do with it. So the thing is, I'm kind of coming here thinking, well, there's no real legacy problems in Ruby. If there are, afterwards, talk to me about it, and we'll figure out what's possible. The thing I did want to talk about today a bit, though, is do you think you write good code? Okay? That's a very funny thing to go and ask rhetorically of a very large crowd like this. It's kind of like, do you think you write good code? Of course, everybody says, yes, I write good code, right? But the thing that we have to go and also ask, though, is how do we know? How do you know that you're writing good code, right? Now, this is funny. We all have different ideas of what good code is. And if you've been around the industry for a while, you've talked to a number of people, you've seen books, you've seen people talk about various different principles of good design. Hopefully you've gotten in contact with people who basically know a bit about design and they can kind of look at stuff and say, that's not so good the way that is. It's like, make it better this way. It's kind of cool watching David's talk as he's talking a number of times about how to simplify expression and remove duplication and boilerplate, which goes and makes things very, very awkward in the context of the work that we do. But the thing is, I want to explore this a little bit deeper, though, because we think we know what good code looks like, but is that something that we really all agree upon? So let me go and show you some legacy code. Oh my God, is that good code or bad code? Well, I'm waiting for somebody to scream out, no, it's Java, it can't be good code, right? What's wrong with this guy? He's at RailsConf, he's going and showing us Java code, right? Okay, but man up a bit, okay? Right? So we have some code here. Seriously, though, do you think this is good code or bad code? How many people think it's good code? How many people think it's bad code? Yeah, what's bad about it? Somebody scream something out. All the strings are in the code. Yeah, they should be in the database, right? Resource file or something along those lines, right? But things read pretty well, and could it be worse? Yeah, it could be a lot worse, right? Okay, so admission, I wrote this code, okay? And I actually find it rather useful for the work that it's intended to do, okay? This is basically written in an older version of Java. It's not the latest version of Java. It's something which is used for a tool that needs to be run in many different environments where people have old JVMs and stuff along those lines. But, I think it's reasonably expressive. It kind of moves along. Better, though, I'd really like to go and have code that reads like this, okay? I love this kind of short, brief, simple code, right? Pretty much the one-liners, the things where, well, if it's not just one line, it goes and gives you just a couple of lines, and you can basically find out You look at the method name and you see the intention, and then you look at the code inside of it and you see what's going on. It reads like English. You have a good sense of what's going on with things. It's a shame that in Java we can't approach this quite as easily as you guys can in Ruby, but still we can do some pretty cool things. Now what about this code over here? Is that good code or bad code? Bad code, right. I wrote this code too. And I'm proud of this code, okay? And I'll tell you why a little bit later. But actually, I left this code in the state that it's in for a decent reason. Okay, so there's something that was really interesting I read about 6 months or so ago. There's a friend of mine who sent me this paper from the Onward conference at UPSLA. This is kind of like the old-timey conference for going and doing object-oriented programming. Still around, still lots of interesting insights and stuff. But this paper was basically talking about good design and how it comes about and what it really maps to. And the thesis of this paper by a guy named Tom Mullen was that essentially good design is good because it kind of maps the way that our brain works, right? So if you look a little bit at this sort of thing, you say, well, gee, what would be good for us? Well, the typical things that we kind of know. You want to have clarity of expression. You want to have good naming, things along those lines. It's nice to have small methods, right? It's nice to have small classes. Anybody enjoy large classes? Yeah, they get kind of crazy at times, right? But the thing that was so funny in this paper is that he talks about these various things, and he talks about them and he says, essentially this is really good code for novices to go and basically have these small methods and small classes, but the experts don't really need this stuff. And I thought, whoa, that's like totally not what I was expecting to read, right? Because most of the very experienced programmers that I know, they try to aim for smaller classes and methods, and they aim for economy of expression and all these other things. But it took me a little while to go and dig through the paper and understand what he really meant by this. When he talked about an expert, he said, if you have an expert, they have this mental map already, right? So they can kind of look at this big, long method, and they can see things kind of fitting together, and they have memories they can draw back upon, and they don't need the crutch of having small methods and small classes in order to go and really do the work they need to do, right? So it seems like if we're experts, we should write cruddy code. Does that make sense? But here's the insight, right? Experts in what? Okay, if you're an expert in an application, right, then you have that mental model about how everything ties together. If you're not an expert in that application, then you don't really know. And in essence, the thing we have to kind of get to as a realization for all of us is that we are all novices to a degree, right? If we join some other project, we have to go and basically ramp ourselves up to what's going on inside that particular project and move on with it. After 3 months, I'm a novice in my own code, right? It's like I look at this, and I'm kind of like, what the hell? What did I do, right? So you have to go and sort of look at it again and start to go and build up that mental model again. And as you're doing this sort of thing, you arrive at better designs. So I was talking to somebody the other day at a very large software organization, and he had an interesting insight. He said, we hire really top-notch developers. And I said, well, how do you know they're top-notch developers? And he says, well, they do all the right stuff in the beginning, okay? And what they did is they all know principles of simple design. They write small classes and small methods and things along those lines. And they all really kind of know the party line. They know how to go and move forward and do really cool things. But after a little bit of time, they start letting a little bit of cruft go and sort of sink into their code. And at first, they're kind of like, yeah, this is okay. I understand what's going on with this. I'm happy to move forward. And then they get to the certain tipping point. And at that tipping point, they're kind of like, oh, hell. It's kind of like, what do we do now? They've kind of realized that they can't really sustain the way that they're doing things at that point in time. They have to kind of march in and start doing some extensive refactoring to go and get things back towards simplicity. And it's funny because for them, it's seductive. They become experts in their own code base. Kind of wild. So where do we get all these coding guidelines that we hear about? Okay, I work with Object Mentor, and it's like for years we've been talking about design principles. We've called many of these from various different parts of the industry. A guy named Bertrand Meyer. Everybody ever hear of Bertrand Meyer at all? Okay, right. So he came up with a number of very interesting design principles. And it's funny about these things that a lot of them are really things that have basically come up through reflection, right? We reflect on our practice. We look at what we do, and we sort of say, this makes things more understandable. If we don't do it this way, things get messed up, that sort of thing. So it's all kind of like, just like cultural knowledge that we kind of pass from generation to generation, and we march forward with things. The thing I'm starting to wonder about, though, with this is, really, are we right about some of these things? So what do we really know about software development today? Anybody ever hear of the big ball of mud? Okay, this is a pattern that was written up by Brian Foote and Joseph Yoder back in 1997. And that's not, I mean, that's actually a pretty ball of mud, right? It's not spectacularly ugly. But in their paper, what they do is they talk about, back one. Okay, let me jump. They talk about this sort of thing, okay? Essentially code that kind of degrades to the point where it feels like a shanty town. You know, it's like we have, you know, talk about spaghetti code. Look at the stuff on the left there, right? And y'all have been in this kind of style of code base before, I'm sure. Most of us really have been, where you really can't sort of make progress because there's all these crazy things that happen within the context of it, okay? So this is a little thing from the wiki page, big ball of mud, and it kind of describes the kind of system we're talking about here, okay? Unmistakable signs of unregulated growth, repeated distant elements in the system, often to the point where nearly all important information becomes global or duplicated. Crazy stuff. Anybody ever work in a system like this? How did it get that way? That's funny. We can say, well, we're lazy, right? We're lazy. We made this sort of thing happen. The thing that's really funny and interesting for us to think about, though, is that really we did this, right? And there's a reason why we keep on doing this sort of thing. Again? Clients, yeah, we can always blame the client for these things, but no, the truth is we mess up, okay? We really do. The thing that's freaky about this paper, and I encourage you to read it, the Big Ball of Mud paper by Yoder and Foote, is that they actually don't really take a moral stance on this pattern. They just say, look, this is the dominant architectural pattern in the industry today. You end up having this sort of thing. Think about that, right? Is it good or is it bad, right? So it's a funny thing with this. We have to kind of ask ourselves, you know, really, are we on the right track going and thinking about going and having clean code, okay? So we keep on trying. We keep on trying to have clean code and to go and make intelligent, coherent systems. Why do we do this? Because we got to live in this stuff, right? We got to walk into it every single day. We got to do something inside this code to make progress, to go and keep on adding features and doing all these things. We do it because the alternative is painful. But yet, it's kind of like, you know, I'm one who kind of believes in entropy a great deal. You know, when I go bald, I'm really going to go bald. I'm not going to get a toupee, you know. I told friends early on, it's like when my teeth start to go, I'm going to have them all pulled out. You know, I don't want to, you know, entropy wins in the long run, okay? But the deal is, it's kind of like with code, it's kind of like we have to kind of get used to the fact that things do start to fall apart. And we spend a great deal of time going and trying to fix things as they fall apart. And it's worth it to me for us to go and think about this and think about where we can win with entropy, okay? So entropy wins, yet we care, we want to make progress. So I had an insight a while back about this, and I'm hoping to go and sort of do something a bit more with this. And I think that the Rails community is actually an interesting place where this sort of thing can happen. The insight that I had really kind of came from experience with clients. So I get called in all the time. People have a big legacy code base in Java, C#, C++, you name it. And the manager goes up to me and says, you know, what can you do to go and increase our test coverage? You know, our test coverage is at 10% now. We want it at least up to 30%, and eventually we want to have 100% code coverage. And I have to go and say, no, sorry, that's not the point, okay? The point is not to go and have test coverage around everything. You could spend the rest of your career in this gigantic code base writing tests, and they wouldn't really go and give you much benefit because you'd be doing nothing else. You'd spend your entire career working on these things. The insight I had with this, though, is that really there's only certain parts of the code base where things like this really matter. And the notion is that basically having tests in place matters a lot when you need to go inside there and understand the code well enough to make a change. You have to go in, you have to make a change. It's great to go and have support from tests to go and basically make sure that you're making the change correctly. And the cool thing about this, though, is to notice that this is not every place in your code base, right? If you look back through the code bases that you work on today, do you change all of your code equally, with equal frequency? Probably not. There's probably areas of your code that you don't touch more than once every 6 months to 8 months or something like that, and other areas of code that you change all the time, right? So when I work with people and code in large code bases, I say, look, just write tests for the things you want to change. And the cool thing is that since these areas are hotspots, what's going to happen over time is you'll keep coming back to these areas and discover, like, oh, there's tests in place. My life is easier right now. But it's interesting to think about that, though. If there's areas of code which really matter more than other areas of code, what can we really do about that? Can we basically go and adopt something, some other practices? The thing I think that's interesting that we don't really do enough of is looking back through our source code repositories and trying to learn things. Okay, essentially, with all the stuff that we have in source code repositories, we can discover wonderful things, right? You can kind of hunt through things and figure out where are your hotspots, where are the areas of code change that happen most frequently in your code base. And then you can concentrate on those particular areas. And I often recommend this to people. Take the areas where you have the most change and try to do something about them, okay? Look and see what happens when people go and do a bug fix. Does it go and tend to lead to cascading bug fixes in other areas of the code? What's funny for this is that we can actually do like real science in our code bases by going and hunting through our commit histories and trying to figure out what we can learn and basically use that to kind of feed back into our process. An interesting thing that's going on with Google right now is that they've released an API which allows anybody in the world, well, I guess you have to have some kind of agreement with them, any researcher to go and basically use an API to go and get a hold of their code through the version control system and run metrics on various things and use that as like fodder for going and learning more about how software development happens in the wild. And there's so much we can learn by this. Is this the same as those design principles we were talking about a little bit earlier? Not really. This is really empiricism, right? This is basically going back and saying, you know, let's assume for a minute that we don't know the best way to write code. Let's instead go back and try to go and figure out what we can figure out by looking at the way people make changes in code bases. And the cool thing is we have that data. We can do something about that. So I'd like to propose 3 little experiments, okay? It's kind of funny because I was in the speaker's lounge yesterday and somebody was walking around and saying, oh, you know, so what are going to be the things from your talk that people can take away and do immediately? I'm like, oh, it's the keynote. I'm not quite sure I'm going to touch on something very specific, but I decided to go and add a couple of things that I think are really cool that you can go and experiment with. One of them is basically to go and look through profiling information for your application, find the most executed paths of your code, and really, really investigate them. When you find the most executed paths of your code, you find areas which are critically important to your application. Those should be clean areas of your code. Should all of your code be clean? Yeah. But these areas of your code should be way clean, right? Because these are going to be pieces of code that even if you aren't looking at them periodically because there's a maintenance issue with them, you know that they have to be right. They have to go and work consistently. If they don't, you're going to get it through the bug log at some point in time. The other thing is to try out something. I'm calling it open-closed whack-a-mole. Okay? So have you all heard of the open-close principle? I mentioned Bertrand Meyer earlier. Okay? Open-close principle. The idea is that when you do write good code, you typically don't have to go back into existing code and change it much. Instead, you write new code that's kind of called out from the old code. The way Bertrand Meyer put this is he says, good code is open to extension but closed to modification. Right? So if you look through the commit history of your code base and you find one area where things are going in and just really getting hammered, you're getting lots and lots of changes in this area, look at that stuff and go and ask yourself, well, gee, how can I orient the design in such a way that that isn't the focus of change anymore? Okay? So you can do various things, introduce polymorphism, whatever, and then basically it's going to go move the variation out into other areas of the code, and then guess what happens? As you look through your commit logs, you can go and discover that other areas are getting a bit hammered. So you go and move on and move on and move on. The thing that's cool about this is that it all can be empirical. You can go and basically search for that information, understand where things are happening in your code base, and use that as a way of moving forward with things. The last thing, or the sort of last thing I wanted to go and talk about, was the Run Dojo experiments. There's something I'm hoping that researchers in industry start doing, and I think it's something which is actually a really cool thing to do on a team right now. One thing that I think we don't know enough about is the way that the current configuration of code actually affects the way that people make changes in code. We have a lot of anecdotal knowledge about this, right? But what I'd love to do is do something like this. Take the same piece of code, put it in front of 30 different developers independently, and say, look, we want you to add a feature to this particular piece of code, and see how they do it, right? Okay, take the initial set and vary it a little bit, kind of reduce the size of a switch statement or something along those lines. Do the same thing with the same group of people. How do they basically make a change to that code, right? Now, as much as we like to think of ourselves as like very reasoning beings who sort of, it's like, oh, I know what the right thing is, I'm going to do the right thing, and that sort of thing. At the end of the day, we're confronted with situations, and those situations bring forth all sorts of associations for us, which basically help us decide what we're going to do next. Time pressure, culture, all these other things. I think to the degree that we actually learn way more about how we react when confronted with a particular piece of code, we can start developing very empirically based coding guidelines for people and say, yeah, it's not just that by anecdote we kind of know that this is better. It's like we can actually point back and say, look, when things are structured this way, there's an 80% chance people are going to go and do it that way. If we go and we structure things this way, then there's like a 70% chance. And that kind of thing, that kind of feeding back of information to ourselves within the community can really, I think, make a big difference going forward. So for extra credit, one last thing, research your repository. Gold mine of information. I was talking to somebody at Google the other day, and they said, well, one of the things that they were looking at with their code repository is when a bug is found, what's the first thing that's changed afterwards? The test or the source code? How quickly does the change occur? What's the frequency of change in that area afterwards? All that sort of stuff, we have the damn data, right? We have version control systems. We can learn about what it is that we really do. Okay, so I feel that we're kind of moving into this. It's not just me. There are a lot of people out here basically going and saying, look, you know, we can start to go and establish more reasonable guidelines for ourselves based upon empirical evidence. We have the ability to go and dig into things and that sort of thing. It's funny, I was talking to Glenn Vandenberg yesterday, and he's going to have a session on software engineering after this, after the break. And one of the things that he mentions a bit is that it's only when money really gets involved that people start to go and get really scientific about things. One of the things that's kind of, I guess, yeah. One of the things that's kind of funny about this is that, you know, I'm sure y'all are aware of the Agile community. It's kind of like, this is kind of like, it seems like the Rails community is kind of like off to the side. They've kind of fully absorbed what Agile is, and they don't talk about the word Agile much anymore. But the later thing that's happening now is basically lean. People are going and trying to take lean manufacturing processes, kind of tie them into software development and do various things. There isn't all that much that's happening in the area of code right now. Some people are digging into it. Josh Kiryevsky, I was talking to him the other day, and he's kind of digging into this also. We can start to go and get practical information about how much it actually costs to write code. We can get practical information about how much money we make with particular bits of code. What happens when we feed that back into the development process? Seems like it could be rather powerful, and it has the potential to change the way we do things. So this is that method I wrote, and I didn't refactor it. And I'm proud of that method. Am I just wrong? Anybody know why I left this one alone? Well, it works. Sorry? Never used it. No, it is used. Actually, it is used. And what's very funny about software development is that there are certain relationships that just tend to hold true, like the power law of method size, for instance. It's like you're going to have, in any code base, a small number of very large methods and a whole bunch of really small methods. And it tends to follow a power law distribution. That just tends to be true no matter what. I don't know why. I think it's mainly because we're biological creatures and we're subject to biological law. So this is one of the long methods in a code base that I've got. I left this alone because I wasn't quite sure which way to refactor it yet, and because I trusted the developers I was working with. Now, the developer I was working with was myself. So we'll see how that goes, right? But the thing is, I've seen this in certain high-performance teams where you're working with a group of people and they know what good design looks like. They know what small methods work like. But sometimes you'll see code like this, and they're OK to leave it this delta away from good. And why are they OK with leaving it this delta away from good? The reason why is because they know the next person going in there is going to look at that and say, OK, I've got to make a change to this now. This one needs to be touched. They aren't going to make it worse. So they can be like one delta away from good, tight, clean, simple code, but they're kind of leaving their code poised on the precipice in a sense. Maybe precipice isn't the great word, but poised for change. This is a method that's pregnant with expectation. Is that redundant? We don't know which direction it's going to go in, okay? But this method will be changed the next time that somebody touches it if we are working in a good culture and a good team. Is this absolutely clean code? No. But if the practices surrounding this are good, then we know that we can leave code in this slightly off state, and it will get taken care of because we trust the people who are working on it. And I think that basically for us, the very cool thing is to go and start to define what this little delta away from best is, so we can go and understand, what the best way of making changes happens to be in a code base and make that a bit more empirical. So I hope that wasn't too theoretical and researchy and stuff like that, but it's something I thought might be kind of useful. And thank you very much.